Good morning, good afternoon, everyone. My name is Isin, and today I'll be presenting my assignment 3 for visual programming. My project title is AI Perception and Reconstruction, and this is an interactive digital art piece by me. Before diving into the project, this is a quick introduction. As mentioned, my name is Su Isin, and I'm a part of Group FCM1. My lecturer for this course is Ng Yi Ki. Okay, moving on to the project introduction. AI perception and reconstruction explores how machine sees and understands us. This is the artwork function in two parts. For first, AI perception. The cameras acts as the eyes of the AI, capturing movement as raw pixel data, not a complete image. It's a data level, non-figurative way of seeing. Next, AI reconstruction. This raw data is then processed by a digital system, which acts as the AI's brains, recognizing this fragmented perception into a new abstract visual form on screen. This is the AI's unique interpretation of human movement. The resulting visual and abstract and dynamic, representing how the AI thinks and presents its perception. This project invites us to consider when a machine understands us through data, what does it truly see? The next slide is the artwork reference and inspiration. My artwork was inspired by leading digital artists known for their interactive and data-driven creation, specifically Refik Anadol and Zachary Lieberman. Okay, for the next slide. This is the video reference. In terms of technical approach and understanding how to achieve real-time interactive visual, I heavily reference on tutorials. One particularly helpful resource was a YouTube tutorial titled Touch Designer Tutorial Flame-Man Interactive Art, which demonstrates technique for translating human motion into generative art within Touch Designer. This is the key software for this project. For the last slide, primary uses real-time camera capture. The webcam continuously monitors the participant's body movements, which directly drive the digital system. This allows your body to become an intuitive medium for dialogue with the digital art. This is the artwork screenshot that I do. This is the interactive visual project I created in Touch Designer. Starting from the video input, I'll explain each node's function and how the entire visual pipeline is constructed. Step 1 is the video input and basic image. Video device in 1. This video device in 1 which capture the real-time video feed from the webcam. Next is flip 1, which flips the video horizontally to create a mirror view, a more intuitive layout for interaction. Catchy 1 and Catchy Select 1. These two nodes work together to store the previous frame. We'll use this later for frame differencing. Diff 1. Diff 1 compares the current frame with the previous one to detect motion and dynamic change in the image. Connect with trace 1, blur 1, and limit 1. These nodes perform thresholding to binarize the image, then blur and limit to smooth the edges and extract clean contours. Next, connect with Fit 1, RGB Key 1, and Null 1. Feed 1 resize the image. RGBQ1 extract specific area based on color, and null 1 acts as a clean output reference. Step 2 is doing the noise composition and feedback. Noise 1 generates animated noise, which I use later to add visual distortion and motion variation. Okay, this is a custom GLSL shader where I apply pixel level or color manipulation. GLSL and noise connect to composite 1 and composite 1 connect to feedback 1. I combine the process image and noise in composite 1 and set it to feedback 1 to create a trailing or ghosting visual effect. The next step is converting data for 3D visualization. Connect feedback 1 and composite 1 connect to cross 1, reorder 1, max 1, and pose. These nodes convert image data into position value to be used for 3D particle representation. Color 1, add 1 and convert 1. Color 1 adds color to the points. Add 1 generates the point cloud, and convert 1 turns the data into SOP format for 3D rendering. Now is the 3D rendering. Geometry 1 holds the geometry, and camera 1 is the visual camera. Render 1 renders the 3D scenes. For the constants 1 provides a background or reference plane to complete the composition. Render 1 connect to feedback 2. Feedback 2 adds a second layer of visual memory, enhancing the motion trail in the 3D environment. Next step is to post-processing and color correction. Level 1 adjusts brightness, contrast, and black-white level to enhance the clarity of the feedback output. Composite 2 blends different visual layers together and enhancing the complexity and depth of the scene. Feedback 3. Distant feedback loops help maintain and extend visual trace over time. Level 2 connect to level 2, a second brightness adjustment after feedback 3, used to fine-tune the look and avoid overexposure. Connect to composite 3. Composite 3 fuses the image again with other components, preparing the visual for final color mapping. And the last step is color mapping and output. Rem 1 defines a gradient that sets the color style. I use it to replace grayscale values with colorful gradients. Connect to composite 3 and Rem 1 connect to lookup 1. Lookup 1 applies the gradient color from Rem 1 to the image, like a custom LUT or color map. Last 2 is RGB key 2. RGB key 2 removes a specific color like a background and isolates the key visual elements. Finally, Null 2 is the output anchor. I use it to finalize the visual for displays or further use. Conclusion. Let's wrap up the whole Touch Designer project, from webcam input, motion detection, feedback loops, 3D rendering, to dynamic color output. This system builds an engaging real-time interactive visual experiments. And this is my final assignment.